Lesson 1.6 is going to talk about the rules of logic. And so just like in a game, if you don't follow the rules, you're cheating. If you don't use valid legal rules of logic, you won't be able to get the right results or the same results. So all of these that are going to happen here are called rules of logic. And we are going to go through 4 of them. These are things that you should learn and should be able to recognize the pattern of them, both to apply them and, say, to know on a quiz or a test. So we are going to start with a direct argument that says if P is true, then Q is true. We're going to start with true statements. And we are going to start with P implies Q as a true statement. So we know both of these are true. We're going to say P happens, P is true, therefore Q is true. And this is easiest seen in a picture. When you're doing these diagrams, the then is always your large set, and the if is always your subset. So what this is saying is P implies Q is true, P happened, P is true, so whatever P is happened, therefore no matter what happens, Q has to happen because that is a subset. So that is a direct argument. Notice that this is the if that happens, and we can conclude the then. The order of these is very important. If we go to indirect logic, we're going to start with that same P implies Q, but this time we are going to say not Q. Now notice I said not to the then part. And then our conclusion is therefore not P. Again, if I draw you a picture, here's my Q, my large set, here's my P. This time I said not Q. If I say not to the big set, the little set, the subset, is automatically also not going to happen. So one of the typical examples, easy examples I like to use is dogs. So if Q is my dogs and P are labs, okay, if I buy a lab, then I've bought a dog. That's true. I bought a lab, therefore I bought a dog. So indirect is a similar sort of thing. If I use my dog example and my lab example, if I buy a lab, then I bought a dog. I didn't buy a dog, so there's no way that I could buy a lab. Obviously, I went out here somewhere and I bought a cat. Something that's not a dog can't be a lab. So the OR rule also does something similar. Here I'm going to say P or Q. Now remember what this means. P could be true, Q could be true, or they both could be true. So that picture looks like this. In order to guarantee to know where my desired result is, I'm going to say not to one of them, not Q. Therefore, my conclusion is P has to happen. If I take Q completely off the table, that eliminates this spot, it eliminates that, and it forces my desired result to be over here at P. I could also say not P, therefore Q. Chain rule is a lot like a transitive property, so you can think about it that way. If I say P implies Q and Q implies R, therefore what happens? Well, let's draw a picture. If P implies Q and Q implies R, therefore whatever that baby subset of P is would also be R. And the key with this one is that the then of the first becomes the if of the second. So if I use my dogs, and then I use hunting dogs, and then I use labs, if I buy a lab, then I buy a dog. If I buy a dog, or if I buy a lab, then I buy a hunting dog. If I buy a hunting dog, then I buy a dog. You can see that it works. If I buy a lab, then I've bought a dog. So you can see how you get more specific as you move inside these sets. So how does this look in practice? So example, we're going to write a valid conclusion for the true premises and tell which rule of logic the argument illustrates. Amy will get an A in the course if she gets at least a 90 on the final. So this has that inverted order. So I'm really thinking about this is my P and this is my Q. So P implies Q. If she gets at least a 90 on the final, then she'll get an A in the course. Here's my conclusion. Amy got a 94 on the final. On the final, on the final, that means P happened. My conclusion, therefore, Q has to happen. What's Q? My conclusion is Amy gets an A in the course. And this is an example of direct logic. Cows eat meat or they are herbivores. Here's my or. So this is P, this is Q. So the pattern I'm looking at is P or Q. So obviously I'm looking at the or rule. Cows do not eat meat. Eat meat was P, so I have not P in this line. Therefore, by the or rule, Q has to be true. So if I think about the picture, so P is over here, which is meat eaters. Q is over here, which is herbivores. Obviously, the and is the omnivores, and I say they are not meat eaters, therefore Q has to happen. Therefore, cows are herbivores. Now this last example, as soon as I see two statements, I start thinking chain rule, and I'm going to assign a letter to each part. And I'm going to say if a number ends in 0, there's my P, then it is divisible by 10, there's Q. If a number is divisible by 10, there's Q again, then it is divisible by 5. There's my R. So I have P implies Q, Q implies R. Therefore, by the chain rule, P implies R. So my implication is if a number ends in 0, then divisible by 5. How does that look in a picture? Divisible by 5 on the all the way outside, divisible by 10, and the most specific subset is that it ends in 0. So if it ends in 0, it's divisible by 10. If it's divisible by 10, it's divisible by 5. So just a quick summary. Valid arguments use patterns of reasoning called those rules of logic we just went through. There are 4. Rules of logic involve the given statement and produce conclusions, the therefore part. If everything is true, then the conclusion must be true. If you've applied a rule of logic in a correct way, then it must be true. Invalid arguments don't correctly apply the rules of logic. There's some mistake in the pattern usually. So let's look at this one. X equals 4 only if x squared equals 16. So here's my P and here's my Q. Remember, only if is one of those backwards ones. So I have P implies Q, and I'm going to say not P, therefore not Q. So what's wrong with this? Well, let's draw a picture. I hope most of you see that the counterexample, or the problem here, is that x could be 4. But how does that work in a rule of logic? So this is my x squared equals 16. Here's my subset that x equals negative 4. When I said x is not negative 4, I eliminated that, but there was a whole nother set that said that x could be 4. I didn't completely rule out that that was false. And so this is an invalid indirect, because it should have said not Q, therefore not P, if I wanted it to work. In the next one, ABC is a rectangle, then it is a quad. ABC is a quad, therefore it is a rectangle. So here's my P, here's my Q, so I have P implies Q. ABC is a quad, so I'm going to say Q happens, therefore P happens, is what the words say. But how does it work in a picture? So here's my Q, and this stands for all quads. Here's my P, which is rectangles. Now what did that rule of logic say? It says P implies Q, it says Q happens. Q happened. It happened out here. It could be a kite, or it could be a trapezoid. But you can't force it to be a rectangle when you say Q happened. Q happened, that's a true statement, but it does not have to be this conclusion. So this is an invalid direct argument. So biconditionals and definitions will be covered in the next video.